Hey everybody, welcome back. We've got a busy lesson today. Here's what we're going to do. We're going to look at a couple more algorithms for our linky list. We're going to look at removing it an index, and we're going to look at removing a specific object. So we're going to look for a specific, in this case, a specific int value and remove the first instance of that. Then we're going to jump over to generics and subclassing abstract collection. We've already looked at generics pretty extensively in a previous unit, so I think we'll be ready to just tackle that right as we go, and it should flow very nicely. So, without further ado, let's get started. First method I want to do is remove at an index. So how are we going to do that? Well, we've got a list, and our list doesn't specifically have indices built into it because it's not an array. But we can give it an implied index, 0, 1, 2, 3, and we know that each one of these next values is pointing to the next value in our list, right? And then we have some variable called first, which is pointing to the first one. So let's describe what it would be like to remove an node or an item from our list that is not the first item. So let's say we want to remove at index 2. Well, the only way we can get there is to start at first, and we have to count how long it's taking us to get there. So we'd say, okay, that's 0, that's 1, then boom, we found it 2. So what we want to do is we want to keep going until we get to 1, index 1. And what we want to do is we want to take that next, and we want to just bypass this and connect it over here. So typically when we remove a value, we return, if we're removing an index, we typically return the value at that index. So we might want to grab a next.data first before we do assign next to that. All right, well, what if we are going to remove the value at the very end? Would this still work? Sure, we're just going to go to one index short of the end and connect it all the way to null. So basically, it's a pretty easy procedure. It's just a matter of changing where that next is and skipping this. And since nothing else is going to be referencing this node 2, the garbage collector will just collect it for us. But what about if we're trying to remove from the front? Well, that is a slightly different situation. The way we're going to do it is we're simply going to change first from connecting to here to here. So we're going to have a special case. It's not hard, but we will have to have a special case set apart for us for when we're removing at index 0. So, and in fact, actually, we don't even need to do that because we've already got that method written, right? We've already got remove from front. So if they call remove and it is the first index, we'll just call remove from front for them. All right, so let's jump right to it. So we've got to remove from, my mouse is fighting me. It's trapped. All right, let's see. All right, we've got to remove first right here. So let's just do we're going to add 2 more removes here. Public int remove int index. That's an important operation, right? So I'll do the first part. If index is equal to 0, then let's just call remove first. Now, remove first returns the int that's there, so we'll just return what remove first returns. Remember, we're calling a method in a class that we're in, so we just say the name of the method, remove first, and that'll do it. Okay, so the alternative, and you could use else, but you don't have to since this if statement did return. If it gets to this point, we know that it was an index, not 0. So what I need you to do is to iterate through the list until you get to the correct index -1. So if they give you index of x, you need to be at x -1. So make sure you count that way. Use a while loop to get there, and then kind of skip over, but make sure you get next.data first so that you can return it. All right, pause the video and give it a try. All right, let's see how you did. So I need a count, right? I'm going to say int I equals 0. I'm going to say while I is less than index -1. So what if they gave me an index of 1? Well, then 0 is not less than 1 minus 1 is 0. 0 is not less than 0, so it would just skip this procedure, which means we're already at the correct place, right? Oh, but I need something else. I need to get a current node. So I'm going to say node current is equal to first, right? And then what I'm going to say is for each time, I'm going to move current to current.next, and we will increase our I. All right, once we get to this point here, all we need to do is just kind of bypass it. So I'm going to say int d equals current.next.data. Remember, we're removing next, okay? When we're looking at removing the index 2, I'm sitting here, so I need current. So this is current right here, right? Current is here because we started it first and we pushed it along till we got to here. So current.next.data would give me that data that I need to return before we remove or after we remove. All right, then I'm going to say current.next equals what? I need to skip over. How do I do that? Current.next.next. And I'll return D. All right, so that was kind of tricky, some subtleties you may not have thought of. Don't feel bad if you didn't get that one, all right. But hopefully you understand the procedure. So let's take a look at how it works out. All right, let's add a LinkedList. Don't worry about this other class. We're going to use that in just a second. Let's add. I'll add them in order. Remember, we're continuing to add to the front because that's what our linked list does best. All right, let's get a two-string on that bad boy. 654321. All right, I'm going to remove. Wait, let me look at that again. That's 0, 1, 2, 3. I'm going to remove the 3 that's at index 3. That's kind of confusing. Let's remove the 4 that's at index 2. 0, 1, 2. So I'm going to say remove at index 2. Should return the 4. It does. Let's check out our two-string. 65321. Boom, it works. Okay, cool. Let's do another one. This time I want to remove a specific item. So we're going to do public Boolean. That's usually the way the remove works here. We're going to return true if we actually removed it. And we're going to say remove int value. So this time we're removing a specific object. It's a little confusing because we've got two methods with the same name. Yeah, oh wait, it's not going to let me do that, is it? Yeah, even though it has a different return. I thought maybe it would allow me. So let's say remove value. We'll call it remove value. All right, that'll work. Now, I'm forgetting my fundamentals. Okay, so how is this going to work? Well, basically the same way. All right, we're going to iterate through, but what we're not going to be iterating through for a count. We're going to be iterating through we're going to be iterating as long as current.next data is not the one we want. So we'll start with current right here at first, and we'll check current.next, which goes here, data. And if that's the one we want to remove, then we'll do that little crossover. But again, we do have a special case if the item that we're trying to remove is at the front. So we'll need to be careful about that. Also, notice I realized that when we did remove int index, we did not check if the index was the proper index and that it could throw an index out of bounds exception. So you should probably do that. Otherwise, you're going to get a null pointer exception, and that'd be really confusing, wouldn't it? If you did a list and you're like, I want to remove this index, but it's too big and it says null pointer exception. You're like, what do you mean null? Right? So we should probably fix that, but I'm gonna have you fix it, and I'll fix it later myself. But you add that exception to call. All right, let's do this one. So if first dot data, let's start this together, is equal to the value. That means we need to remove first. Then I'm going to say remove first and return true. I'm not going to return what remove first did because we're returning a Boolean in this case. All right. Else, what should we do? Well, this is what I'm going to let you do. Loop through, iterate through the values using your current equals current.next until you find that current.next.data is the one you want, or if current becomes null. So if current becomes null, then you know you've gone too far and you need to return false. Well, actually, current.next, since we're calling current.next.data, it's actually current.next that can't be null. So loop through until you current.next equals value or current.next equals null. In fact, check current.next equal null first so that you don't get a null pointer exception. Use the short circuit nature of AND. Give it a try, pause the video, and then we'll talk about it. All right, let's see how we did. So I'm going to say int index equals, not index, I'm sorry. Node current equals first. I don't need index anymore because we're not using indices, right? Okay, my mind is stuck on that other method. All right, so I'm going to use a while loop. While current.next does not equal null, and current, actually that's all I'm going to do, to tell you the truth. A little different than I described it earlier, but this is the way I'm going to do it now because I can change things. I can do that. So while current.next does not equal null, if current.next.data is equal to the value that I want, then I'm going to say current.next is equal to current.next.next. And I will return true. So I don't need that condition here, actually, because since I'm going to return, that's going to break the loop anyway, and that's pretty much all I need there. So what happens if we make it all the way through the end? Well, then we need to return false because we did not actually find the value. Let's compile, and we'll give it a try. All right, so I'm going to add some stuff here. Actually, you know what? I'm going to do it over here, just for fun. I'm going to say linky list equals new linky list. And I'm going to say for int I equals 4, I less than 20, I plus equals 2, list.add I. Oh, it's add first. So when you're in the interactive shell, you can't do curly braces for a for loop. You can only do one line of code. You have to do it all on one line like that. But that works. So let me take a look at my list. I'll pull it over. And look at the toString. Pretty cool, huh? So there we go. I went from 4 up to 20, not including 20, increasing by 2s. All right, let me look at that toString one more time. All right, I think I want to remove the 10. So I'm going to say, see here, Boolean remove value. Now, earlier we had to change these names. And the thing is that when you do remove an object, when you're dealing with collections, that object will be of type E. When you do generics, I mean. And this one will be of type int. And so that's why that name collision doesn't normally occur. But for us, it did. For here, I said I was going to remove a 10, so let's do it. Should return true, or it could sit there and think for 10 years. Okay, what did I forget to do? Oh my goodness, I forgot to advance it forward. Okay, so if we don't see it, if current.next.data is not equal value, I need to advance it. Current equals current.next. All right, that's what needs to happen. We need to add current. So if we don't find it, add current equals current.next. Okay. Now I'm going to make a new linky list. Oh, probably have to restart the thing. Let's try it again. All right, making a new linky list. And I'll do that. I'm going to add some stuff to it. And then I'll just bring it over here to my workbench. So just kind of a quick way for me to get all that stuff. Let's check out the toString. Okay, got 4 through 18. I'm going to remove 10. So we will remove the value 10. It says true because it found it, and it shouldn't be there anymore. 18, 16, 14, 12, 8, 6, 4. Cool. Let's do remove value 99. False. Okay, that's exactly the one because it didn't find it, didn't remove it. All right, so that's the remove methods. Now it's time to implement abstract collection. So I've got the API up here, the Java documentation, and I've looked up abstract collection, java.util.AbstractCollection. It takes a generic. So this class provides a skeletal implementation of collection. A collection is the most basic kind of iterable kind of collection of items like a list, okay? But it's even more basic than a list. So abstract means it's going to do a lot of these really ridiculous methods. Look at some of these methods take a long time to write, and all they're basically doing is calling your other methods over again. So they're just kind of like helper methods. They don't really do a lot. They're not that important to the backbone structure, but they take some time to code. So we're happy to just take theirs. Now, you'll notice size is abstract, iterator is abstract. So we need to do those. But additionally, the add is not allowed. So in order for us to actually use this collection and modify it, we also need to override add even though it's not abstract. Abstract methods you have to override. So we have to override iterator and size, and we're going to override add. So when we write our iterator, we are not going to override remove yet. We'll do that later, okay? But we'll definitely need to because this remove method here, this is an optional operation. So this method's not going to work until we provide the remove method from the iterator. So note that this implementation throws an unsupported operation exception if the iterator returned by this collection does not implement remove. So the remove object from this abstract collection is kind of cool. You don't put the code to remove there. It creates an iterator and removes it that way. So we need to make sure that our remove works before we do that, but we'll do this in stages. So what I want you to do is add this linked collection E. All right, we're going to need some imports. Let's import abstract collection from java.util, iterator, and no such element exception. And we're going to say that linked collection of type E extends abstract collection E. Remember, when they use our linked collection, they will supply what they want. They could be anything. They could be, heroes, Mario characters, tables, chairs, integers, not ints because they have to be objects, strings, you name it. Any class you want can go right here. But for us, we're calling it E. That's the generic type. Okay, let's get going. First, we need to make a private nested class to hold our information, right? So let's do that. I'll keep it towards the bottom. So we'll just type everything up above this. So private class, what? Node. What's it going to have? It's going to have some data. What's the type of the data? E. Private node next. So not much has changed here, right? Not much. Private node, when we create a node, we need some data. I'll just call it E. So this is just kind of standard style. Capital E is the type, lowercase e, E for element. But I like to use the variable data. So, all right. So there we go. The only thing that really changed was this E, right? Not much there. It's continuing to give me an error saying I haven't done size. When I do size, it'll say you haven't done iterator. So don't worry about that right now. All right, so let's talk about what kind of fields we're gonna need for this. Some instance variables. Well, we're gonna need our first node. We're gonna need our size. So let's do that. Private node first. private int size. Let's get that size method out of the way right now because we have to do that. And we'll, hey, maybe it'll be happy now, right? Nope, because we haven't done iterator. We'll come back to that. Okay, so if we're going to make this collection work, we're going to have to be able to add to this collection. So let's do that right now. The method is public Boolean add. I'm going to show you a nifty little trick here. When you go to the API, and again, I'm using API 9 because it's easy to search. You can click right here on abstract methods and it'll actually show what you need to do. Those are the two we have to do. But we also have to do add and this, you know how it says optional operation? That means currently it's throwing a no such element exception. So this implementation throws unsupported, not no such element, excuse me, unsupported operation. So we need to override this to make sure that it works. So we're going to override it. All right, you know the drill. We're basically adding first. So pause the video, do the add first right quick. Okay, let's see how you did. Node temp equals new node with the data of E. Then we're going to say temp.next is equal to first. And then temp first becomes the reference for first gets our reference to temp. Okay, so that looks pretty good. I do need to increase size though, and I do need to return true. We're not going to have a situation where we can't return, where we have to return false, because we're not putting any restrictions on what can be added. There are certain collection types that do put restrictions, you know, for example, no repeat elements or something like that. Excuse me. But for us, this is fine. Okay, so we've got our add. That looks pretty good. But we still can't do it yet because we have to apply an iterator. Remember, the abstract list actually made an iterator for us, which was super cool. But you probably need practice making iterators, right? So it needs a method called public iterator, because that's the type. And then the name of the method is iterator. I know, it's awful, right? So there's a couple different things we could do. We could write all the code here in what's called an anonymous nested class. I'll show you what that looks like. So I could say return new iterator, and this looks like I'm instantiating, because iterator is a interface, so it looks like I'm instantiating an abstract class, but I'm not, because I put these curly braces and then I put all my code right there. I'm not going to do that right now, though. You can look into that if you want. I'm just going to make another nested class. So I'm going to say return new it. All right. So let's make another nested class, right? Private class it is going to implement iterator. Iterator of type E, actually. So and I should have put that here as well, because if I don't say that, then the iterator will only keep the objects typed as object. So yeah, we should put the type E there. So I'm not putting the E here, because if I put the E there, it's actually going to create a new generic of type E, because it's a smaller scope, and then you have like E .e, and it's just like garbage and it's very confusing. So we're not going to put another letter here because that's just more to keep up with. But we do need the E here on the implementing. Okay, so our iterator, we know how to iterate through this. We've been doing it, right? You're going to start it first and then boom, 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 right there with a call of current equals current.next. So I'm going to make a node called current. We'll call it private just for fun. Class is private, so it's really kind of redundant to do that, but we're going to do it anyway. Makes me feel good about myself. Private it, and all this, when you call a constructor, it just sets current to first. That's going to be the first thing. So what we're doing with this particular iterator, if we were to go back and look at this, we're we're going to create a node called current, just like I've shown here. It's going to point right here to first. If this node, if current is pointing to a true node, not null, then we are going to be able to return that node's data. So as we iterate through, when we call next, remember next is what you do to move the iterator forward and get what is that next value. When we call next, we're actually going to return what current is currently sitting on and then push current forward. So when we write has next, the simple rule is, are you sitting on something that's not null, basically? So I'll say this needs to be public in order to implement iterator. These methods are public. So public boolean has next. I'm just going to ask, hey, is current not equal null? So as long as current is not null, we'll be returning true, and that we have next. All right, now we get to write next. Public E is going to be returning something of type E, which could be, again, any class that they supply. So if our current null is next, or we could say if not has next, then let's throw an exception. And I'll just leave it blank for now. You could put some quotes in there if you want. All right, that looks good. So if we get this far to line 37, we know that we definitely are okay. So I am going to say E data. I'm going to get the current data. That's what I'm going to return. I'm going to return this data right here. And I'll say current equals current.next. And I'll return data. All right. That looks pretty good to me. We really don't have a full collection yet until we override the iterator's remove, because right now that remove method is unsupported operation. But we'll come back to that. So let's make a collection. So I'll right-click new linked collection of type, how about string? All right, so I'm going to add some strings here. C's. Thank you for telling me that you added it. 7. The. And you can add whatever you want, though. World. I'll add a couple more. The. Traveled. And I. Cool. Let's go to our toString. So you might be wondering, wait, does this toString work? Does this work? Well, it does, because guess what it uses? Our iterator. I traveled the world in the 7 seas. I had to put it in backwards to make it spell that, though. So I had to keep thinking. Anyway, so there we go. That works pretty good, right? Already got a toString for us. That is totally clean. There's a lot of things we could do. We can remove all from the certain. Actually, we can't. We cannot remove. If I try and remove the word the, you're going to say yeah. See, unsupported operation. Yeah, it's not allowed yet. But that's okay. We can pull out an iterator though. Let's get one. All right. So let's see. Has next. True. Notice that the next is replaced with string because that's what it is up type. I traveled the. Now the remove should remove. Oh, nope. Unsupported operation. I'm just messing with you. I knew that was going to happen. So we know that these methods here remove should remove what was last called from next. This void for each remaining, in case you're wondering, this is what allows you to use for each loops with collections. That's what the for each loop actually uses. And let's see, is there anything else that we should check out while we're here? There's the isEmpty method. That's cool. See, I don't think clear will work either. So yeah, there's just not a lot you can do because all these things use that remove method. We could probably use this object to array this, so that'd be cool. Yeah, it's an array of type object, but look, it's got all our words in there, so it remembers that they're strings. So anyway, that's pretty cool stuff. Let's go ahead and fix this, man. We have got to get this going to where we can remove. So we're going to go down here to... Now, the remove method in the iterator actually doesn't return anything. It's just void. And we want to remove what was last called by next. If next was not called, you're supposed to throw an exception saying no call to next was made. And you shouldn't be able to do remove twice in a row. So I think we should probably go ahead and make sure that happens. So let's make sure that happens. So we'll say private boolean next called because they have to have called next, okay? So when they create it, next called is false. And then when they call next, before we return the data, we're going to say next called is true. And then we'll set that to false whenever they remove. So you can't remove twice in a row. And we know also that that way they've at least called next once. So we don't have to worry about being out of bounds or anything like that. So we're going to say if not next called. It's an illegal state exception. And I think it's in java.lang. Do y'all remember? Because I don't. But I think that's what it is. It'll get mad at me if it's not there, though. And if it's in util, let's import it. Okay, so it looks like it's okay. So we're going to throw a illegal state exception if they haven't called next. If they have, what we need to do, though, is we need to remove what's behind them. And therein lies the rub. See, it's going to turn out that this is going to be easier to do later than it is right now. So we're going to have to... So what I'm saying is what makes this difficult is... So let's say we've got current sitting right here, okay? You know, and we're like, okay, so if current's sitting right here, then the last thing that was returned is actually this right here. This is the last thing that was returned to them. Because remember, we advanced them forward. Well, how am I supposed to erase this? Well, I've got to have something all the way back here. So I've got to have some previous node way back here that I can link up to like so, which is kind of ugly, right? So let's do. There's one way we could do it. We could just write. We could just start at the beginning and go until we reach what current is. We could do that. So we're going to do something that is kind of slow, but oh well. At least we'll be able to remove, right? And it'll be good practice for our algorithms. So what we're going to do is we're going to create. We're going to actually do an on remove within an iterator, which is painfully slow. But here we go. So what we're going to say is node current is equal to first. Now that first is from way up here, right? And we're going to be looking for, we're going to be looping until we find the value that where its next dot next is us. So let's see how we can do that. We do have a special case though. Let's say if current. Oh, we need to throw an exception. Remember, we have to throw an exception if we did not call next. So let's make that first. So the rule is if you haven't called next recently, you have to throw an exception. So I'm going to say private boolean next called. which will make false. And then as soon as they call next, we'll go ahead and make next called true. And when they call remove, we'll make next called false. So maybe you remember that, maybe you don't, but you can't, when you use an iterator and you use remove, you can't remove twice in a row. So, and you have to have called next at least once. So if our current, let's say if our current node that we're on is equal to, it can't be equal to first. That's not allowed, right? Because that means they've never called next. Oh, actually, let's do this. If not next called, then we're going to throw a new Java. No, I don't. It's not java.util. It's just no such element exception. And you can fill in some stuff there like you haven't called next yet or whatever. Oh, well, I'll go ahead and do it. No call to next made. All right. Or more specifically, they haven't called one since remove or anything like that. So we know that they can't be at first, right? But if the current node is equal to first.next, then what that means is I need to remove first. And the way I do that is I simply say, well, then first becomes first.next. Now it's over. Okay? And return. We're not returning anything because it's void, so I'll just call it done. All right? All right, so that's that. Now, otherwise, we know that we're not at... we've already looked at how to remove the first element if we're sitting on the second one. So we're at least here on the third. So we'll say, basically it's what we did earlier. I'll let current equal first, and I'll say while current dot next does not equal... Ooh, I made a new current, and that's bad. I already have current. Oops. Let's call it node previous. How's that sound? Nah. Let's just call it temp. Well, temp.next does not equal current. All right. Yeah, no, that's bad to try and make current. I was rewriting current. That would make my iterator not work very well. All right, so you notice I'm not checking much here to see about a null pointer exception. There just can't be. There's no way that this can happen without me eventually coming to what my current is situated on. And we know that current is not at first. We already checked if it's at the second position, so we just keep going. All right. Now, you may be wondering, what if there was only one element in the list? Well, first.next would be null, and then current would be null, and null equals null. So what we're going to do when this happens is we're going to say temp equals temp.next. So while temp.next. So while I didn't call it I changed my mind because I don't want to call it previous because that's going to be something I use later. So this is temp. So while temp.next does not equal the current. So we're going to start here at first, and we're going to say, hey, temp.next, which is here, .next, which is here. Boom, it equals current, and we'll stop. And then when that happens, we just do this. Okay, so we've looped through, and we've found, if we get to line 57, we know that temp.next is where we currently are. What we want to remove is what we're behind what we are. So I want to take temp.next and connect it to temp.next.next. So temp.next needs to equal temp.next.next. So I'm taking this node's next reference and saying you go to what is next.next. So I'm bouncing right over it. Okay. Let's give it a try. I am going to, let's see here. I got it here already. I'm just going to create a linked collection, okay, and called list. And I'm going to do a little for loop. I'll say for I'm doing of type integer, so I can do this. For int I equals 0, I less than 20, I plus plus, list.add I. And what's going to happen is I is a primitive, but it's going to auto box to an integer. It can do that. Now, it can't cast and auto box at the same time, but it can do that. So by cast, I mean like if I was giving it a double, it can't make it into an int and auto box. Likewise, if I had a list of doubles and I try and give it an int, I need to make sure they're doubles first. It won't auto box an int as a double object. But that's what it's called, auto boxing. Okay, so let me pull that over our workbench for what that's worth. And let's call that toString. You can find it, it's originally written in objects. You can find it here. It'll say redefined. It's also an abstract class. I'm going to remove the 7. Let's get rid of it. So abstract collection, remove the object 7. True. Let's run the toString. And 7 is gone. Pretty cool, huh? So now we can do all sorts of stuff. We can do remove all and give it like a different collection. So let's try that. I'm going to make a collection. I'll just do it from here. Of type integer. And I'm going to give it a bunch of odd numbers. Okay, so I'm going to say like add 1. Let's add 3. Let's add 5. And I'll go ahead and add 7 as well, even though it's no longer there, but it should still work. So I've got a collection full of these odd numbers, and so I can go here and I can say from abstract collection, let's remove all of those. And true, it's going to return true as long as it removed at least one number. And let's take a look at it. So you can, see those odd numbers, they are gone. That is pretty neat. So there's lots of things we can explore here. Retain all is interesting. It's where you give it a collection and say, I only want you to keep these, everything else get rid of. We can do contains. We can now clear it. That works too now. So lots of stuff here to use. Pretty neat, huh? Okay, let's practice with just the iterator right quick. So we'll get the iterator. Has next is true. Next is inspect the number 19. It's an object, so you got to inspect it. Let's go to next. Inspect this number 18. Let's remove. I just called remove with my iterator. Let's go to toString. 18 is gone. That's it. Linked collection, generics, super cool stuff, LinkedList. I'll see you next time.